Welcome. In this session, we are going to discuss how to solve simultaneous linear equations by matrix method. So we start by describing the method and then do an example to illustrate how the method works. So the key thing is to solving simultaneous linear equations by matrix method. So the first thing you have to arrange the equations such that corresponding variables are in same column and constant terms are on the right-hand side. So this is what I mean, that you have two equations, A11 x1, A12 x2 equals to B1, and then arrange the other one as A21 x1 plus A22 x2 equals to B2. So such that we have x1 in line, x2 in line, and then the constants are on the right-hand side. Now, step 2, once we have rearranged such that constants are on the right-hand side and variables on the left-hand side and in line, next, form the matrix equation. From 1 that is, once you have done this arrangement, so the matrix equation will be given by, check the coefficients of each variable. So A11, next is A12, this one is A21, this one is A22, and then put in those brackets to show there's a matrix. And then the first variable takes the first position in this other matrix. Second variable x2, you put it here. And these constants, you arrange them in this order. So this is what we call the matrix equation. So we have like this matrix A times vector of the unknowns x1 and x2, and you get the constants a vector. So number 3, find the determinant of A and its inverse. So once you have formed the matrix equation, this coefficients matrix gets its determinant that is going to help you get the inverse. And two things can happen. If determinant of A is 0, So this means that the matrix is singular. Then A has no inverse. And hence the simultaneous equations have no solution. But if determinant of A is non-zero, then the simultaneous equations have a solution. So in case this applies, then you go to number 4, pre-multiply. If I call this one maybe star equation star by the inverse matrix to get, this must only be the condition. So you get an identity matrix after that pre-multiplication times the variables matrix, and then you'll get some numbers here. Say C1, C2. So which on simplification will give you x1 after multiplying this matrix and this matrix, you get x1, x2 will be this C1, C2. So x1 will be C1 and x2 will be C2 as the solution. So let's demonstrate how this method works on specific examples. Example 1. Use matrix method to solve this system. Two x 3m minus n equals to 5, and 2m plus n equals to 5. So here you are lucky because the equations have already been arranged. So the first step is already done. So what you do now, form the matrix equation. So we'll have 3 minus 1, 2, coefficient of n is 1, and have the first variable m, second one n, and then have 5 as the constants matrix. So where this now our A matrix. So then next find the determinant of A, which would be 3 times 1 minus 2 times minus 1, which is 3 minus minus 2, which is 3 plus 2, which is 5. Now, because the determinant is non-zero, solution of the system exists. Now, the inverse of A you write 1 over the determinant of A, and then interchange elements along the main diagonal. And what we call the main diagonal is this diagonal. This is the main diagonal. So interchanging means 1 takes the position of 3 and 3 takes the position of 1. So we'll have 1, 3. And then elements in the other diagonal remains in their position, but their signs are changed. So 2 becomes -2, and -1 becomes +1. So it will be 1 over 5 into 1, 1, -2, 3, which is the same as 1 over 5, 1 over 5, -2 over 5, 3 over 5. So remember, if I have a scalar multiplying a matrix, that scalar multiplies every element of the matrix. So next, pre-multiply A inverse on both sides of matrix equation, i.e., pre-multiply means the matrix A inverse will be on the left-hand side. So I'll have 1 over 5, 1 over 5, -2 over 5, 3 over 5, and then we have 3 minus 1, and then we have 2, 1, mn. So pre-multiplication means also you start with the inverse on the right-hand side. Then the constants matrix is 5, 5. So usually we have to multiply row by column. So we have 1 over 5 times 3. So this row times this column, plus 1 over 5 times 2. Then the other element will be 1 over 5 times -1 plus 1 over 5 times 1. And then so have this second row times the first column, -2 over 5 times 3 plus 3 over 5 times 2. Second row, second column, -2 over 5 times -1 plus 3 over 5 times 1. This is m, this is n. Row by column, so 1 over 5 by 5 plus 1 over 5 by 5 minus 2 over 3 or 2 over 5 by 5 plus 3 over 5 by 5. Now, this will give us 3 over 5 plus 2 over 5 minus 1 over 5 plus 1 over 5 minus 6 over 5 plus 6 over 5, 2 over 5 plus 3 over 5. I'm simplifying this first matrix. This is m, n. So 1 over 5 times 5 is 1. 1 over 5 times 5 is 1. Minus 2 over 5 times 5 is -2. 2 over 5 by 5 is 3. Now 3 over 5 plus 2 over 5 is 1. minus 1 over 5 plus 1 over 5 is 0, minus 6 over 5 plus 6 over 5 is 0, 2 over 5 plus 2 over 5 is 1. One plus 1 is 2, minus 2 plus 3 is 1. 1 by m plus 0 times n is m. 0 by m is 0 plus 1 times n is n. Hence, m equals to 2 and n equals to 1. So that is the solution of that given equation. X equals to 2 and y equals to minus m equals to 2 and n equals to 1. Example 2. Solve. Solve the simultaneous equations. Seven P minus 26 equals to 2Q. And we have 5Q minus 29 equals to minus 6P. So the first thing you have to do in this question, arrange the equation such that variables are in line and constants are on the right-hand side. So we'll have 7P minus 2Q equals to positive 26. And then when this brought on the left-hand side will be 6P plus 5Q, take negative 29 to the right-hand side, and then we have 29. So that is the first step. You must always arrange so that variables are in line and constants are on the right-hand side. After arrangement, then form matrix equation. So 7 minus 2, 6, 5. Then P, Q, 26, 29. So this is our matrix A. So next, find determinant of this matrix A, which is 7 by 5 minus 6 by minus 2. So 35 plus 12, because minus minus. This is going to be 47. So next, get the inverse of A, and A inverse will be 1 over the determinant. Interchange the elements on the main diagonal. So 5 takes the position of 7, 7 takes position of 5. Then change the signs of the elements on the other diagonal. So this becomes minus 6. This is positive 2. Then pre-multiply A inverse on both sides of matrix equation. So this we have 1/47 into 5, 2 minus 6, 7, multiplied by 7 minus 2, 6, 5, then PQ. Pre-multiply means you start by the inverse, so 1/47, 5, 2 minus 6, 7, 26, 29. Remember, matrix multiplication is sensitive to order, so you have to be very careful to follow the correct order. So here we have 1/47 into 5 by 7 plus 2 by 6, so row by column. Element here will be 5 by minus 2 plus 2 by 5. Then we have minus 6 by 7 plus 7 by 6. So this row times this column. Element here will be minus 6 by minus 2 plus 7 by 5. So this second row times second column. Five by 26 plus 2 by 29 minus 6 by 26 plus 7 by 29. Now I have 1/47 into, so 5 times 7 plus 2 by 6 is 47. 5 by minus 2 plus 2 by 5, I get 0. Minus 6 by 7 plus 7 by 6, I get 0. Minus 6 by minus 2 plus 7 times 5, I get 47. So 5 by 26 plus 2 by 29, I get 188. Minus 6 by 26 plus 7 by 29, I get 47. Now 1/47 times 47 is 1. 1/47 times 0 is 0. 1/47 times 0 is 0. 1/47 times 47 is 1. And this must always be the thing that once you take the inverse times the matrix, you get the identity matrix. So if you don't get this structure after pre-multiplication, know that there's a problem with your computation. We check. 1/47 times 188 will give you 4. And 1/47 times 47 is 1. Now multiplying identity matrix by this, we just have PQ, which is 4, 1. And from this, P equals to 4 and Q equals to 1. Those are the solutions to that given equation. Number 3, use matrix method to determine the solution of the following simultaneous equations. So x minus y equals to minus 3, 3x plus 9 equals to 3y. Now, the first thing that you have to do is to rearrange the equations such that the same unknown variables are on the same side and in line. And then next, put constants on the right-hand side. So here we have x minus y equals to minus 3, 3x minus 3y equals to minus 9. Then form the matrix equation. So we have 1 minus 1, 3 minus 3, x, y equals to minus 3, minus 9. So this is our A matrix. So determinant of A will be 3 by minus 3, 1 by minus 3, minus 1 times 3, which is minus 3 plus 3 to give us 0. So which means A has no inverse. But rewriting given equations in the form y equals to mx plus c, we have, now you see the first equation will be take y to the other side, so it will be y equals to x minus 3 plus 3, because now take this to the left-hand side and take this to the right-hand side. This other one will be actually divided through by 3. We have y equals to x plus 3. So you see, these are actually similar equations. Y equals to x plus 3. So both are similar. Hence, the given equation has infinitely many solutions. So if you are to draw this simply a line, x-intercept is, so we have y equals to x plus 3. X-intercept means when y is 0, so minus 3, and y-intercept is when x equals to 0, 3. So this will be where this is 3 and then this minus 3. So this is the line y equals to x plus 3. So has infinitely many solutions. So therefore, come and correct here on these steps. When the determinant is 0, as we either have infinitely many solutions or we do not have, so determinant is 0, so M has no inverse, hence simultaneous equations have infinitely many solutions. Have infinitely many solutions. Let's check whether it's also a possibility of having the determinant to be 0 to be a case where there are no solutions. So for example, if we have, solve. The equations y equals to 4x plus 10 and 2y equals to 8x minus 11. So solution, we rearrange first 4x minus y equals to minus 10 and 8x minus 2y equals to 11. So that we have 4 minus 1, 8 minus 2, xy equals to minus 10, 11. So this is our A matrix. So determinant of A will be 4 times minus 2 minus 1 times 8, which will be minus 8 minus minus 8, which is 0. So which implies A has no inverse. But a quick check on these equations, we have this one is y equals to 4x plus 10. And this will be, you can divide through by 2, divide by 2, divide by 2. So y equals to 4x minus 5.5. So we see that these two lines have the same gradient. So which are parallel lines. So if we were to represent this on a graph, so we have equation y equals to 4x plus 10, y equals to 4x minus 5.5. So y-intercept of this, if I call this one line 1, this one line 2, y-intercept of this will be 10. Let's say 10 is here. And then this other will be negative 5.5. So say negative 5.5 is here. And then x-intercept when y is 0. So for this other line, we'll have 5.5 equals to 4x. So 5.5 divided by 4 is x is 1.375. So let me say here is have 1. And then the other one will be 4x equals to minus 10, x equals to minus 2.5. So this is negative 1, negative 2. So this way I have say negative 3, negative 2.5 here. So we'll have a line, this line here. And we have this other line. So this is the line y equals to 4x minus 5.5. And this is the line y equals to 4x plus 10. So these two are parallel, these lines are parallel. So this line and this line are parallel. So there is no solution. So no solution. So therefore, when the determinant is 0 for the coefficients matrix, there are two cases. Either we have infinitely many solutions or no solutions in case of parallel lines. So therefore, when determinant of A is 0, then either we have infinitely many solutions, or we have no solution. So that's how we work out solutions to simultaneous linear equations involving use of matrix method. Thank you.